We'll travel country to country, volcano to fault line, meeting mountains, meeting the maps beneath our feet, and learn how eruptions and earthquakes shape lives, landscapes, and the future of an entire continent. In the eastern reaches of the Democratic Republic of the Congo, the Virunga Mountains hold a volcano as famous as it is terrifying, Mount Nyiragongo, a 3,470-meter peak with a summit crater that hides one of the fastest, most fluid lava lakes on Earth, a lake that, when it spills, travels like a bright, unstoppable river down the mountain's flanks. Nyiragongo sits roughly 12 kilometers north of the city of Goma, a city of hundreds of thousands who live and work beneath its gaze. The DRC's national population is vast, roughly 109 million people, and in this region lives an intense mix of urban life and fragile infrastructure that complicates any volcanic emergency. Nyiragongo is not a mountain that rumbles gently. It has produced lightning-fast lava flows that race down slopes and into towns in minutes. In 1977, fissures opened and hot, low-viscosity lava slithered into villages so quickly that thousands could not escape. 2 decades later, in 2002, a catastrophic flank eruption sent molten rivers into Goma itself, destroying homes, killing people, and forcing a chaotic exodus. In May 2021, Nyiragongo erupted again. Fissures opened and lava moved toward Goma's outskirts. The 2021 event showed how sudden these eruptions can be: crack, flow, and city on the edge. The volcano's lava lake is historically persistent, and its eruptions have alternated between summit activity and sudden lateral fissuring that can reach populated areas. Why does Nyiragongo behave this way? The volcano lies in the western branch of the East African Rift System, where Earth is pulling apart. The magma that fuels Nyiragongo is exceptionally low in silica and very fluid. It can travel downhill faster than most lavas. That means eruption on the summit or rupture along the flank doesn't simply fill a crater. It can send rivers of molten rock rapidly into the human landscape. Mount Nyiragongo's summit crater is about 1.2 kilometers across, and its lava lake has been active intermittently since at least the early 1970s, with major effusive events in 1977, 2002, and 2021. These events are not regular in a predictable way. The volcano cycles through quiet decades and sudden violent outbursts that transform the terrain and the people who live below. Smithsonian global volcanism. One of the most chilling risks in the region is not only the lava, but the presence of vast volumes of dissolved methane and carbon dioxide in nearby Lake Kivu. Large disturbances may destabilize those gases. A sudden release could become a regional catastrophe. The 2002 and 2021 eruptions reopened the question of what happens when volcano, lake, and city sit so close together. Nyiragongo's eruptions have destroyed homes, severed roads, and disrupted power and services. Cropland is buried under black flows. The volcanic ash alters soil chemistry, and the burnt landscape invites erosion in the next rainy season. For the communities of Goma and surrounding villages, the economic and psychological toll is persistent: lost livelihoods, cycles of displacement, and the far-reaching damage to infrastructure that can take years to recover from. Another behavior is in Nyiragongo, Democratic Republic of the Congo. A broad shield volcano slopes, gas plumes, satellite imagery of flows. Not far from Nyiragongo sits Nyamuragira, another volcanic giant in the Virungas. Nyamuragira is a vast shield volcano that produces large volumes of fluid lava, reshaping the rift's highlands and adding new layers to the landscape. While Nyamuragira's eruptions are often less immediately catastrophic for densely packed cities, their volume and frequency have repeatedly changed local ecosystems and forced pastoralists and farmers to adapt to new terrain and ash-laden fields. The two volcanoes in close proximity mean the whole region is volcanically busy, a landscape where the Earth's pulse is continuous. Smithsonian Global Volcanism. Erta Ale, Ethiopia. The Afar Depression, sun-scorched plains, a molten lake glowing in the night. Far to the northeast, in one of the planet's most desolate places, sits Erta Ale, a low black shield volcano in Ethiopia's Afar Depression. It is a mountain of modest height, roughly 6 and 13 meters above the desert, but with a gargantuan personality. Erta Ale is famed for its long-lived lava lake. Some researchers suggest the lake has existed for well over a century. Other records place persistent activity back to the early 20th century. This glowing eye in the arid land has been called the Gateway to Hell by locals, a name given partly for its remoteness and partly because of the boiling violence inside its crater. Erta Ale's eruptions are a direct function of its place at a triple junction, where the African, Arabian, and Somali plates meet. The rifting produces magma that wells up as the crust thins. Because the volcano's magma is basaltic and relatively fluid, its hazards are dominated by overflowing lava lakes and lava flows, rather than massive explosive ash clouds that travel thousands of kilometers. But the flows can be lethal locally, and the area's isolation makes rescue and monitoring difficult. Eruptions at Erta Ale have periodically threatened local nomadic communities and trekkers drawn to its glow. The persistent volcanic gases and the scarred landscape reduce grazing land and complicate water access. The heat and toxic fumes make the immediate environment dangerous. The island of solidified lava left by repeated flows changes soils and microclimates, and because Erta Ale is remote, the impacts are often underreported. An eruption can burn pasture or a settlement and leave little trace in global headlines. Mount Cameroon, another devastating natural occurrence. Cameroon. Lush forests on the lower slopes, basalt flows, a plume on the horizon. On Africa's Gulf Coast, Mount Cameroon rises like a giant sentry from the rainforest. At roughly 4,000 meters above sea level, the tallest peak in western and central sub-Saharan Africa, Mount Cameroon is both a cultural symbol and a real volcanic hazard for coastal towns below. It belongs to the Cameroon volcanic line, a chain that has produced both volcanic cones and rare but deadly disasters in this region. Mount Cameroon has a history of eruptions over the past centuries. The 1909 eruption even forced colonial administrators to temporarily move. More recently, eruptions in the 20th and 21st centuries have produced lava flows and ashfall that affected agriculture and communities on its slopes. The volcano's size, its tall, forested flanks, means that eruptions interact with a moist environment. Heavy rains on volcanic debris can cause devastating mud flows and landslides after eruptions, multiplying the environmental damage. Ash reduces air quality and settles on farmland, altering crop yields for seasons. Lava covers paths and fields. Fires can scorch forest patches that are habitats for endemic species. Human costs are concentrated in local communities that rely on smallholder agriculture and have limited evacuation options. The mountain's eruptions are irregular but historically significant. The combination of active volcanism and dense forested slopes creates cascading hazards that can persist long after the lava cools. Diving into Ol Doinyo Lengai, Tanzania, the strange volcano. If volcanoes had personalities, Ol Doinyo Lengai would be the eccentric uncle who pops up and surprises everyone. Located in northern Tanzania near Lake Natron and the town of Arusha, Ol Doinyo Lengai is unique in the world. It erupts carbonatite lava, a rare and strangely low-temperature, highly fluid magma that behaves unlike the thick, ropey lavas most of us imagine. The volcano towers roughly 2,962 meters in elevation and is revered by Maasai people as the Mountain of God. Carbonatite lava erupts at much lower temperatures than typical basaltic lavas and weathers quickly into white deposits. The flows are very fluid and can spread thinly over the landscape. While Ol Doinyo Lengai's eruptions are often not catastrophically explosive on a continental scale, their local impacts are important. Ash and lava flows can damage grazing land, change soil chemistry, and disrupt local livelihoods that depend on pastoralism. The volcano's uniqueness also draws scientists and tourists alike, which is a double-edged sword when eruptions spike suddenly. The environment around Ol Doinyo Lengai is fragile. Frequent small eruptions deposit new material that alters grazing patterns. The ash and new mineral deposits change the composition of soils, sometimes making them temporarily less productive. Erosion can follow eruptive episodes, and human communities have to adapt their grazing routes and water usage. While Ol Doinyo Lengai's eruptions are not usually the kind that flatten cities, their ecological effects can be long-lasting for the pastoral economies nearby. Volcanoes differ. Some rumble for months, some explode in an instant, others whisper for decades. Erta Ele's lava lake has been a semi-continuous presence for decades, a slow bread-baking churn that occasionally overflows and remakes the caldera. Nyiragongo sits on a hair trigger with the capacity for near-instant flank flows that cross kilometers in hours. Mount Cameroon's activity is irregular, but bound up with intense rainfall and forested slopes, which convert eruptions into secondary disasters like landslides. Ol Doinyo Lengai's odd chemistry makes its deposits different but still locally disruptive. Common environmental disadvantages after eruptions include ash and dust that reduces photosynthesis and contaminates water, fresh lava fields that sterilize topsoil, long-term changes to drainage and erosion patterns, destruction of habitat and biodiversity loss, and often the permanent reshaping of human settlement patterns. For people, the costs are immediate: death, injury, lost homes, and slow: displacement, ruined crops, interrupted education, damaged infrastructure. Many affected regions are poor and under-resourced, which lengthens recovery and increases long-term vulnerability. Diving into Africa's major earthquakes, when the ground trembles. Volcanoes are visible, glowing, erupting, breathing fire. Earthquakes are invisible until the moment they shatter the normal. They strike rapidly. Their destruction is sudden, indiscriminate, and often strikes historic towns, modern cities, and remote villages alike. Surprisingly, Morocco. On the 8th of September 2023, high Atlas earthquake occurred. Crumbling stone buildings in an Atlas village. Western Morocco was struck by a shallow magnitude 6.8 earthquake centered near the high Atlas. Old masonry villages and ancient kasbahs, some centuries old, shook and collapsed. The human cost was terrible. Nearly 3,000 people were killed and thousands more injured, and entire villages were damaged or destroyed. The quake's proximity to historic Marrakech made the headlines. The city's ancient quarters sustained damage, but many of the worst losses occurred in remote mountain towns where access is difficult and homes were built of stone and mud brick that does not withstand violent shaking. This earthquake was shallow. Shallow quakes concentrate energy near the surface and therefore cause greater damage locally. The high Atlas is a fold belt and complex tectonic region near the boundary zone between the African and Eurasian plates. While much of Morocco experiences low to moderate seismicity, Powerful events have occurred in the country's past, and vulnerability is high where old masonry forms the scaffold of traditional towns. The 2023 event impressed upon the nation the need for seismic-resistant design and for rapid humanitarian response in far-flung mountain valleys. The quake destroyed houses, historic monuments, and tourist infrastructure. The collapse of masonry structures sent debris down narrow streets. Displaced families faced harsh mountain conditions. The regional economy, reliant on tourism, agriculture, and local crafts, suffered immediate shocks, while recovery stretched months and years for rebuilding, with heritage conservation becoming a complicated, expensive priority. International aid arrived, but the need for resilient reconstruction remained urgent. Deep diving into Algeria. The 2003 Boumerdès earthquake. On May 21, 2003, northern Algeria, a nation of roughly 46–47 million people today, experienced a powerful magnitude 6.8 earthquake near Boumerdès, east of Algiers. The shock, with a shallow focal depth, ravaged towns and suburbs. Over 200 people died, tens of thousands were injured or left homeless, and entire neighborhoods were structurally devastated. Northern Algeria lies at the convergence of the African and Eurasian plates. The compressional tectonics here make powerful quakes possible. The Boumerdès earthquake underlined how modern cities, dense populations, complex infrastructure, can multiply the damage of a single event. Bridges, highways, and services were disrupted. The economic cost ran into the billions. As with all major quakes, long-term impacts included housing shortages, increased poverty in affected communities, and the expensive task of retrofitting or replacing unsafe buildings. Looking at the East African Rift, a long broken heart. The East African Rift is not a single event but a system, thousands of kilometers of crust pulled thin by tectonic forces. It runs from the Afar Triangle in Ethiopia down through Kenya, Tanzania, and into Malawi and Mozambique. Here, the Earth is literally splitting. That process makes the rift one of Africa's most seismically active regions. Earthquakes in the rift range from frequent small tremors to moderate to strong events. Swarms can occur as the crust adjusts to rifting and magma movement beneath volcanoes. In recent years, the rift has shown intense seismic swarms, dozens of magnitude 4.1 events concentrated in days or weeks, particularly in northeast Ethiopia and parts of Kenya. These swarms are sometimes related to magmatic intrusions and are intimately connected to the region's volcanism. Magma moves, crust cracks, the ground shakes. For local communities, repeated shaking damages structures over time, undermines confidence and safety, and increases long-term economic and social vulnerability. Rift-related earthquakes frequently occur in areas with sparse monitoring and under-resourced infrastructure. Rural communities suffer repeated structural damage to houses and churches, localized landslides on weakened slopes, and sometimes loss of life in larger events. Moreover, seismicity can change groundwater patterns. Wells can go dry or become contaminated after strong shaking, compounding humanitarian crises. Families rebuilding, scientists sampling ash, children in temporary schools. Across Africa, eruptions and quakes share a cruel attribute. The afterlife of a disaster is rarely immediate. The first 72 hours demand search and rescue, but the months and years that follow demand patience, money, and planning. A destroyed harvest becomes a nutrition crisis. A river of lava that cooled into fields drives grazing animals away. Collapsed homes force migration into poorer housing or tent camps. These are slow-moving disasters superimposed onto sudden ones. These devastating earthquakes, eruption quake behavior disasters create for the environment and people long-term soil damage and changes to watercourses, loss of biodiversity where habitats are permanently altered, recurrent displacement that dissolves social capital, economic shocks to tourism, agriculture, and local industry, and recurring risk because buildings are often rebuilt with the same vulnerabilities. Stay tuned for more fascinating stories with your favorite Curious VT.